motion combined with kinematics. A straight slope of length 60 meters, so the diagonal hypotenuse 60 meters, angle 12 degrees, starts at top, speed 5 meters per second, no resistance. Find the speed at the bottom. So we need to find the speed here. To find the speed here, we need the acceleration. To find the acceleration, we use FBD of the object. So for the FBD, we need to identify the forces. This is the vertical weight force, which can be split into W sine, W cos. And actually we have normal force, but we don't care about it because there's no friction. So we only use the force along the slope, which is only W sine. So for the sigma F in this direction, we have W sine equals ma, W is mg, cancel out the m, we have the acceleration. Now that we have the acceleration, we use kinematics. The initial velocity u is 5 down the slope. Let's say down the slope is positive, so the u is 5, and the acceleration is g sine down the slope also, so also positive. That's positive 10 sine 12 from here, and the s is it's going down the slope, so also positive 60. Now look at the MF19 formula. We have u as a, finding v. The formula with u as a v is the one without t, so this is the formula we use. So we use we take the square root. We have square root of u squared plus 2as, plug in the numbers, use a calculator, we get the final answer. The next part, this time we have friction. This is the mu k 0.03. Find the time this time. So now we need to use the normal reaction force and the friction force. The friction is of course up the slope, opposing the motion. So first we use sigma f in this direction, which is perpendicular to the slope. We have r and w cos. Sigma f equals 0 because there is no acceleration in this direction, which means they cancel out. R equals w cos. And from the friction formula, F equals mu r, the R is w cos, we have the F actually. Now for the sigma F in this direction, so in this direction, meaning along the slope, we have the friction and the W sine, and we use sigma F equals ma. The acceleration is down the slope, so this W sine is positive, this F is negative. So this is the sigma F, and now we plug in F equals this, and W is mg, and we cancel out mg, m. So we have the acceleration, we can find the number actually. Now we use kinematics again to find the time this time. So we have the initial velocity u, the distance s, and the acceleration is this from here. We're finding t. Look at the MF19, the formula without v is this, so we plug in the values here. So for the a, let's just say a, just use the store function in the calculator or use the answer button, or if you want to use the value, you gotta use more than 3 significant figures because this is an intermediate calculation. You don't want to lose accuracy for the final answer. Okay, so now we plug in, we have this equation, we subtract 60 from both sides, we have a quadratic. You can solve the quadratic using the quadratic solver in the calculator, or you can use the quadratic formula, and you will get t equals this, reject the negative time. So that's the final answer in 3SF. Alright, I'll see you again next time.